Imagine a vegetable that grows for 20 years, that towers taller than a person, and that produces fresh food every single day, yet never appears in any grocery store. While industrial agriculture depends on crops that die each winter or that can be patented, this tree collard breaks every rule. It almost never sets seed, it evades commercial control, and it only multiplies by hand, forming a hidden food chain passed quietly from neighbor to neighbor. If it is so resilient and so nutritious that it can outlast the toughest seasons and outperform kale, why did we erase it from our fields and forget that it could feed us forever? The search for answers begins here. A single tree collard rises from the soil with the quiet confidence of something ancient. Its trunk, thick and woody like a young fruit tree, supports a crown of broad, waxy leaves that shimmer in the wind. Unlike the soft stems of ordinary kale or collards, this plant forms a true stem, gnarled, scarred, and sometimes as wide as a child's wrist. In mild climates, the trunk can reach 4 inches across. The branches stretch upward and outward, pushing the plant to heights of 8, sometimes even 10 feet. Older plants arch and sprawl, sending side shoots in every direction, each one crowned with a cluster of purple-green leaves. The foliage is dense and layered, with leaves often as large as dinner plates. Their color shifts with the season, from deep blue-green to a smoky violet, especially in winter when cold triggers the anthocyanin pigments. The leaves never drop all at once. Instead, the plant holds onto its canopy year-round, creating a living wall of edible green. Even after a decade in the ground, the trunk thickens and the canopy expands, turning a humble vegetable into a permanent, almost sculptural presence in the garden. Beneath the surface, a taproot drives deep into the earth, anchoring the plant against wind and drawing up minerals that annual crops cannot reach. The result is a perennial vegetable that stands taller than most people and lives longer than many trees in a backyard orchard. Each year, the trunk grows rougher, the bark more furrowed, and the scars from old harvests mark the story of seasons past. This is not a crop that comes and goes with the calendar. It is a fixture, a living food bank that endures through drought, frost, and neglect, quietly gathering sunlight and turning it into abundance. The tree collard is not just a plant in a patch, it is a monument to survival, built leaf by leaf, ring by ring, year after year. A tree collard's lifespan stretches far beyond the boundaries of ordinary vegetables. In gardens where winters stay mild, growers have watched a single plant persist for a decade, sometimes nearly 20 years, its trunk thickening with each passing season. This is not hearsay, it is the consensus of experienced gardeners' nursery records and horticultural guides that describe tree collards as perennial mainstays, not fleeting crops. Most annual vegetables are gone in a year, but here, the same living structure continues to push out leaves, season after season, with no need for replanting. Yet this longevity comes paired with a peculiar reproductive quirk. Unlike kale or collard cousins that bolt and scatter seed after 1 or 2 years, the tree collard rarely if ever enters the flowering phase. In coastal California and other temperate zones, entire groves can go years without producing a single bloom. When flowers do appear, the event is brief and unpredictable. The few seed pods that form contain only a scattering of seeds, and the offspring are never true to type. Each seedling is a wild card, sometimes reverting to a short-lived ordinary kale, sometimes displaying traits that bear little resemblance to the parent. For anyone hoping to save seed, the result is disappointment and genetic chaos. Botanists who study perennial brassicas have long suspected that this reluctance to set seed is rooted in the plant's genetic makeup. Chromosome imbalances, partial sterility, and flower abortion are all common in perennial kale breeding experiments. In the field, growers report malformed flower buds, aborted pods, and low pollen viability, signs that the plant's reproductive machinery is at best unreliable. Yet no one has published a full, cytological map of the purple tree collard's reproductive system. The evidence comes from decades of field observation, not from laboratory charts. For the gardener, the outcome is clear. The tree collard behaves as if it has forgotten how to reproduce by seed. Instead, it invests all its energy into vegetative growth, producing an endless supply of leaves and branches. The only reliable way to keep the line going is through cuttings, snapping off a branch and rooting it in soil. This genetic quirk locks the tree collard out of the commercial seed trade and into a rare category, a perennial food crop that cannot be mass-produced by seed, only passed from hand to hand, clone by clone. The plant's very biology resists commodification, and that resistance helps explain why such an enduring food source remains almost invisible in modern agriculture. Shipping manifests from the 1700s list barrels of cabbages and kales, packed alongside salted meat and hardtack, essentials for sailors crossing the Atlantic. In the damp, wind-battered gardens of the British Isles, perennial kales known as cottager's kale or tree kale stood as living larders, cut back each season, but never uprooted. Victorian garden journals describe these plants as the backbone of coastal cottage plots, with their thick stems and leafy crowns surviving where annual crops failed. By the mid-19th century, tree-like kales were common in Scotland, Ireland, and along the Atlantic coast of France and Spain. Gardeners in the Mediterranean, too, kept perennial collards tucked in corners of stone-walled terraces, prized for their ability to withstand both drought and salt spray. Mediterranean gardeners relied on them. Ethnobotanists point to Montenegro in the Balkans, where families still maintain multi-year collard bushes, propagated by snapping off pieces and rooting them in the spring range. Ethnobotanists have documented this practice. These plants did not travel in seed packets, they moved as cuttings, hidden in soil, wrapped in cloth, carried by hand from one homestead to the next. When colonial ships set out for the Americas, they brought more than just seeds. Hardy brassicas, including perennial forms, were stashed in root balls or tucked into barrels as insurance against crop failure. Over time, these survivor plants found new homes in kitchen gardens from the Caribbean to the Carolina coast. The journey of the tree collard is not marked by a single origin or famous name, but by a web of migration routes, each one leaving its trace in a different soil. One ethnobotanist notes that you find these perennial greens wherever people needed food security and could not count on the market or the weather. Cuttings wrapped in damp cloth, tucked into pockets, or slipped between fence slats, carried the tree collard from one garden to the next. In the Victorian era, cottage journals mention neighbors swapping leafy branches over hedgerows, each exchange preserving a living memory. The plant's absence from seed catalogs is no accident. Without reliable seed, there was nothing for merchants to package or patent. Instead, the lineage survived through quiet acts of sharing. Ethnobotanists recount stories gathered from coastal villages and rural communities where the arrival of a new family meant an invitation to take a cutting home. In the American South, oral histories from descendants of enslaved gardeners describe backyard plots where a single collard bush became a lifeline. When money was scarce and land insecure, the ability to snap off a branch and root it in a coffee can or a patch of bare earth offered a kind of food security that no store could match. The plant's journey is mapped not by official records, but by living testimony. Gardeners in California trace their tree collard back to a neighbor's grandmother, and Scottish crofters recall the kale bush that anchored the winter table. Each cutting is a fragment of an unwritten archive, passed along in times of need, celebration, or migration. The tree collard's invisibility in commerce is not a sign of weakness, but proof of a social technology, one built on trust, resilience, and the simple act of sharing what endures. A mature tree collard delivers a scale of harvest that challenges the logic of annual gardening. Field notes from home growers and small trial plots suggest that a single, well-established plant can yield between 2 and 4 pounds of leaves per month during its prime year. Over the course of a mild season, that is 20 to 40 pounds, enough to fill a kitchen sink many times over. Unlike annual crops that peak and fade, the tree collard distributes its productivity across the calendar, offering steady repeat harvests rather than a single flush. If you follow the plant for a typical productive lifespan, for example 12 years in a favorable climate, the numbers begin to stack up. Rough estimates drawn from garden logs and informal weighing suggest that one plant can produce well over 400 pounds of edible leaves before age or disease finally slow it down. That figure is not a laboratory measurement, but a composite drawn from real gardens where picking is a weekly ritual, and the plant is never left to bolt. To put this in context, a single tree collard occupying the corner of a backyard can outpace the total output of dozens of annual kale or collard seedlings planted and replanted over the same period. The harvest is not just abundant, it is continuous, with no gap between planting and picking, and no need to start over each spring. For anyone tracking food yield per square foot, the tree collard running total is a quiet anomaly in the world of vegetable production. Its output accumulates year after year, a living ledger of calories, minerals, and vitamins that resets only when the plant itself finally gives out. Laboratory tests on ordinary collard greens set a high bar for nutrition, but the perennial tree collard stands apart from its closest relatives. Calcium density is the first surprise. Per calorie, collard greens deliver 4 times as much calcium as milk. That means a serving of tree collard leaves, drawing on the same species group, can supply 170 milligrams of calcium per 100 kilocalories, based on standard collard assays. This is not a trace mineral, it is a structural dose, packed into every bite. Protein content follows suit. In 100 grams of cooked leaves, collards typically provide nearly 5 grams of protein. For a vegetable, that is a remarkable figure, especially considering the plant's ability to keep producing leaves all year. The protein is not just filler either, it comes alongside a broad spectrum of vitamins, including vitamins A, C, and K, and a suite of minerals drawn up by the plant's deep taproot. The purple pigment in some tree collard strains signals another nutritional edge. Anthocyanins, the antioxidants that give blueberries their reputation, are present here in striking amounts. While most leafy greens offer little, purple tree collards can reach up to 420 milligrams per kilogram based on measurements in other purple brassicas. These compounds help protect cells from oxidative stress, adding a layer of health benefit that goes beyond basic nutrition. Taste is the final metric in the lab report. Unlike the sharp, sometimes bitter bite of annual kale, tree collard leaves are mild, sweet, and nutty. The perennial root system pulls up complex minerals, enriching the flavor in ways that annual crops cannot match. For anyone chasing nutrition, flavor, or both, the numbers tell a clear story. This is a perennial green that outperforms the competition, not just in the field, but in the chemistry of every leaf. Industrial agriculture is built on a simple equation. The more uniform a crop, the easier it is to scale. Machines are calibrated for predictability, rows of identical plants spaced exactly 18 inches apart, harvested in a single sweep. The tree collard refuses to play by these rules. Its branches twist and sprawl, each plant growing at its own pace, defying the symmetry that combines harvest with efficiency. For large farms, this unpredictability is more than an inconvenience, it is a logistical headache. Perishability adds another barrier. Standard greens are bred for toughness, able to survive days in cold storage and cross-country shipping. In contrast, tree collard leaves wilt within 2 hours of picking. Their tenderness, so prized by gardeners, means they collapse before reaching the supermarket shelf. Distributors and grocers facing losses from unsellable produce have no incentive to gamble on a crop that cannot survive the journey from field to store. The biggest obstacle, though, lies in the economics of seed. Modern seed companies rely on a recurring revenue model. Every season, farmers and gardeners buy new packets. Each seed is a tiny license, a way to ensure that every harvest starts with a purchase. The tree collard, with its near-total reliance on cuttings instead of seed, breaks this cycle. Once a gardener has a single plant, they can propagate hundreds more. No seed packets, no royalties, no repeat sales. An agricultural economist says the entire value chain is optimized for crops that can be bought, sold, and shipped in bulk. If a plant cannot be patented, cannot be standardized, and cannot be moved as seed, it is invisible to the system. It is not that the tree collard failed the market, it is that the market never had a way to profit from it. In the logic of industrial food, abundance without revenue is a dead end. The tree collard's biology, so well suited to survival and sharing, makes it an outlier, one that the machinery of modern agriculture was never designed to handle. In a world where drought shrivels gardens and late frosts kill seedlings overnight, the tree collard stands untouched. Its deep taproot reaches far below the thirsty surface, drawing water during 30-day dry spells when even established fruit trees begin to wilt. Growers in California and the Mediterranean report the same story. When the summer sun bakes the soil, annual greens collapse. The tree collard's leaves remain crisp and sweet, their color deepening as the plant concentrates its energy into survival. In winter, when temperatures drop below freezing, the plant's waxy leaves and woody trunk hold firm. Reports from Zone 8 gardens confirm survival at -6 degrees Celsius, with only the youngest shoots showing damage. Where lettuce and spinach blacken with frost, the tree collard shrugs off the cold and is ready to regrow at the first sign of sun. This resilience is not theory, it is field-tested. Permaculture growers have run stress trials, letting established plants go unwatered for a month or exposing cuttings to sudden chills. Again and again, the outcome is the same: survival, regrowth, abundance. The secret lies in the plant structure, a perennial root system built for slow, steady gathering, and a trunk that stores energy through feast and famine alike. Even after a harsh season, a single branch can be snapped off, stripped of leaves, and pushed into damp soil. Within weeks, roots appear, and a new plant begins, a perfect clone of the parent, ready to feed another household. This stick method requires no tools, no special soil, and no waiting for seed. It is a technology older than the seed packet, practiced in backyard gardens and permaculture food forests alike. On camera, a permaculture grower demonstrates the process. One clean cut, a handful of leaves removed, a branch pressed into the earth. No fertilizer, no irrigation system, just patience and trust in the plant's will to live. Within a season, the cutting sends up new shoots, and by the next year it is already producing harvestable leaves. This is not a fragile novelty, but a proven survivor, a perennial vegetable that turns climate stress into an afterthought. For gardeners facing water rationing, unpredictable weather, or the limits of time and labor, the tree collard is not just an alternative. It is a quiet revolution, offering food security that grows stronger with every passing year. Right now, most of our food system still depends on fragile, short-lived crops, while a plant that thrives for decades remains hidden in plain sight. In a world facing climate instability and supply chain shocks, true security may come not from new innovation, but from remembering what was deliberately left behind. The future of abundance could begin with a single cutting. Thanks for watching, and share your thoughts below.